Okay, now if we're given that 3 is a 0 of this polynomial, which we are, and let's also make this 13. 17, that's hopeless. 17, 03, 22, okay. If x is 3, this polynomial is 0. You can plug it in and see. But you're given that x equals 3 is a 0, so that x minus 3 will divide the polynomial evenly. And that will mean that the polynomial is x minus 3 times whatever you get when you do the division. So that obviously then when x is 3, the whole thing is 0, and that's consistent with the information you're given that x equals 3 is a 0. So x minus 3 is a 0, so x minus 3 has to be a factor. X minus 3 is a factor, so if you divide x minus 3 into the polynomial, it'll divide evenly. And without going through the details, we show that it's so. And we get this result. And again, everybody, I think, is good with this procedure. So we establish that x minus 3 divides this polynomial with this quotient, so that the polynomial is equal to x minus 3 multiplied by that quotient. Okay? Now, we come over here. We need to factor this. Okay? Now, yeah, okay. Yeah, we're wanting to continue factoring this, and I looked at the wrong thing and confused myself for a minute. But we have x minus 3 times this, okay? And now we want to factor this. And I didn't tell you anything about how to factor this. Okay, but it turns out that it's fairly easy to do this. In this case, now, if I change one number in this, it's no longer easy to do. It's probably impossible. So what you get here won't always be something you'll be able to factor. But if you get it on a test, chances are it's going to be something you can factor. And the only method I'm going to really require you to know for factoring it, because I think the other methods are so rarely used that we're going to kind of skip them. I hate to do that, but you know, we have to make some choices. Okay, to factor this, you have to just find a number that makes it 0. Okay, and then you're going to divide by x minus that number. And it turns out there's an easy number that makes this 0. What's the easiest number you could possibly put in for x? Now, before I wrote any of this out, I asked that, and somebody said, well, 1. 0's no good, because if you put 0 in here, you're not going to get 0, because you're going to have that negative 6 left over. Okay, if x equals 1, let's check out x equals 1. 1 cubed is 1. 4 times 1 squared is 4 times 1, which is 4. And 1 is 1, so we get 1 plus 4 plus 1. That gives us 6. Minus 6 is 0. Bingo. We hit 1. Okay? Now, it won't always be 1. It could be like negative 1. But negative 1 doesn't work here. Or it could be 2 or negative 2. It's going to be a small number, probably plus or minus 1 or 2. Okay, well, x equals 1 works. We plug that in, it gives us 0. So we can divide x minus 1 into this part here. So again, we're trying to factor this. We divide x minus 1 into that, and we get quotient x squared plus 5x plus 6. So now we know that this polynomial, which is x to the 4th, not x squared, plus x cubed, etc., is equal to x minus 3 times x minus 1 times x squared plus 5x plus 6. And you know, we could go further with this. We'd find the zeros of this, and find that negative 2 is a 0, and that leaves us negative 3. So that this would factor into x minus negative 2 times x minus negative 3. Now, if we didn't already know how to factor that, this is the way it would come out, and that's the way I've written it. I didn't write it as x plus 2 times x plus 3, because if we follow the procedure we're using here, That's the way it's probably going to appear. But that is x plus 2 and x plus 3. So now the thing is factored, and we can sketch an x-axis with zeros at what? -3, -2, 1, and 3. Of course, the y-axis would be like right here. Okay, if we plug 0 in for all this, we're going to get 18. So we know that the y-intercept is 0, 18. And we know that all these are zeros. And we know that now the x-axis is divided into 1, 2, 3, 4, 5 subintervals. And we're going to easily be able to determine if x is a humongous negative number, that we got negative here, negative here, negative here, negative here. We're going to get a super humongous positive number because we'll have 4 negatives. So the graph is going to go up on this side. And if x is a huge positive number, all these are going to be positive. We're going to get a huge positive number on this side. Between -3 and -2, we could plug in a number like -2.5, and this would all come out negative. Got to be positive between -2 and 1 because it's positive here. Plug in 2 for x, and you'd have a negative from this one, but this would be positive, this would be positive, this would be positive. So you'd have a negative times 3 positives if you plug in 2, meaning that it's going to be negative here. So you're negative here, positive and getting big here, positive and getting big here, negative here, positive here. So your graph is going to do something like this. Now, it's not really going to look exactly like that, but again, the subtleties of exactly how the graph looks are kind of beyond what we can expect to do in this course. But there's your picture.